In this question, we're asked to rank these objects in terms of increasing kinetic energy. So the 1 should be the lowest kinetic energy, and 2 should be the next, so on and so forth, until we get to 4, because there are 4 objects. Here we're given satellites and the speed at which they're moving. In chemistry, we usually think of kinetic energy of atoms, which has to do with their mass and their velocity. So kinetic energy, Ke, sometimes written as E sub k, equals 1/2 mass times velocity squared. M is the mass and V is the velocity squared. The mass should be in kilograms and the velocity should be in meters per second. A kilogram meter squared per second squared, which is the unit you will get when you do this math, is equal to a joule. And you can either use Ke or E sub k. Both are used depending on the context. Here, though, we don't actually need to do the math. So here, the first object is 7,800 kilograms, moving at 4,000 meters per second. The second object is heavier, but it's moving at the same speed. So in relation to each other, this object, because it's heavier, this satellite is heavier, moving at the same speed, will have a higher kinetic energy. And the next object, it's heavier and it's moving even faster, so it will also have a higher kinetic energy. And then finally, a heavier object moving at the 4,000 meters per second. So among the objects moving at 4,000 meters per second, this one, and this one, the heaviest one will have the highest kinetic energy because it's mass times velocity squared. However, in this case, the heaviest object also has a higher speed. So this will be the absolute greatest kinetic energy, which in this case is ranked 4 because 4 is the highest. Now, among the ones moving at 4,000 meters per second, the lightest one is 1. So 7,800 kilograms is 1. Followed by 8,320 kilograms, which is 2, followed by 8,920 kilograms, which is 3. So this is how you would rank these in terms of their kinetic energy.